morning, QCon. So first I have to do my own tech support, I think. So I've been told to press escape and to see if this will work, unlock my Mac. Right, is this working? It is. Thank goodness for that. Right. What a room and what an introduction. Thank you so much. And thank you to QCon for giving me a chance to talk about this. Advanced Message Queuing Protocol. We'll talk about what that thing is in a minute if you don't know. But Advanced Message Queuing Politics. Yesterday, we had a keynote here. There was a story about the future. 20 years ago, AMQP was a story about the future. This is the trip report. It's probably the best way to think about it. And it's a story of people and passions and visions and competitors and friends. It's all about people making technology. So I'll get my clicker here, get going. But I'll start first with a once upon a time. Once upon a time, there was a bank. It was JP Morgan. Hopefully, talking about it's okay here now, all these years later. And they had thousands of traders trading equities on 5 continents. And this is the type of picture you'd see in trading rooms around the world. And that's not how they do it today. In fact, banks is not where this happens today. But back then, we had this problem. We had all these people. And making the technology of the 1990s, early 2000s work was really tough. And one of the things we'd done was we'd built, in the bank, we'd built this amazing messaging middleware system that could transport positions and price information to each individual trader and tailored for them what they were doing. And it worked really well. It worked over slow networks of 256 kilobits in Hong Kong. Incredible stuff. Now, it worked so well that the engineers got bored of it, and they moved on to do something else. And this became a risk for the business. And one enterprising chap in the firm said, I know what, I'll take this software off you, and I'll build a company around it, and with that company, I'll be able to support you. And the bank thought, that sounds like a jolly good idea. And so that's what happened. The company went off, managed to commercialize the product quite successfully. But the CEO was not making as much money as he wanted to make. And he looked around at the bank he had left and thought, So at the next renewal, they came in and they asked for an utterly exorbitant amount of money, or they'd turn off the trading system. They'd turn off the trading system. We wondered why they'd spent the last few years building a license manager into it. So that is the business case for AMQP. And I don't think I've told anyone that before. So I'm John O'Hara. That introduction was basically everything you needed. I'm a board member at Adaptive. They're speaking later today. They make trading technology for the cloud. I'm a board member at the company I founded, TaskGuys, which is interbank workflow, acquired by Euroclear. I'm an advisor to Fidelity and Man Group. I'm an executive, a past executive at all these banks. And today I do technology advisory and I also help mentor startups. That's what I do. But 20 years ago, I was a distinguished engineer at JP Morgan, and I made software, and I was really into software. JP Morgan. Walk along the embankment, and you will come to 60 Victoria Embankment. It's a beautiful building. The front of it is the old City of London Boys' School, and it's been preserved immaculately. And behind this, there's a giant office block, a low-rise office block. Incredibly high-tech, and it floats in the mud by the Thames. That's the building floats in the mud. Quite amazing. And in the 1990s, 2000s, JP Morgan had the saying, more PhDs than NASA, more software engineers than Microsoft. And I worked there. And I didn't know if that was true, but it certainly felt like it was true. And it came home to me after 3 years of working with the bank. I stayed there 16 years. It's only 16 years before I ran out of challenges there. It was an amazing place. They were building an investment bank from scratch. The people were luminous. The challenges were amazing. The technology was great. The funding was ample. And, but the third year, I was writing a Swift gateway for a new derivatives. Here it goes again. It's very strange, that. Let's stop. I think my apples would be reliable. Working again? Yeah. 3 years in, writing the Swift gateway for a derivatives trading system. And we put it live. And I watched as the first message came up in the system. The first thing it did was make $2 billion of collateral calls. And I just stared at the screen and thought, well, that's the most interesting console message I'll ever see. Really brought it home. So over the years, over the 16 years, I worked in every part of the bank, front, back, every line of business, chief architect across these different lines of business. And all of them used middleware. And the middleware was arcane. It often, back in 2002, didn't work at the scale that we were operating at, and we would frequently write our own. And by 2002, I had written 3 middlewares in addition to doing my job. And we weren't alone. Other banks were doing this as well, and some were spinning them out and commercializing these things. And I thought, this is really annoying. If you were to buy a commercial middleware back then, and the leaders were like, IBM MQ series came to market in 1993. Tibco EMS came to market in 1997. The leading products would charge $25,000 per CPU in 2000. And you think what that would be in today's money. And I thought, this is absolutely nuts. This stuff needs to be everywhere. And if you get me going over a pint, you'll hear me rant on about microservices and how much I think HTTP is a terrible protocol for microservices, which I won't do here now. You should be using real middleware. And the first thing that banks do when they get an external request from Fix or from Swift or from anything is they offload it onto a proper middleware, right? And so I wanted someone to sort this out. Someone's going to solve this problem. It's a really obvious problem. This stuff should be in the operating system, and it wasn't. Someone's going to solve this. So first, what is message-oriented middleware? And the easiest way to think of it is it's managed delivery for your data, packaged up into messages, and delivered to another computer system. That other computer system might be in a different part of your organization, might be inside the system you're writing, might be in a different company entirely, might be in a different part of the world. And it's managed delivery. And we all know how lovely managed delivery is with our Amazon Prime. We can watch things move, and oh, look where the van is now. My goodies will be here really soon. Oh, look, they've given me a picture of my own front door. Imagine if we had that for computer systems, right? Can you imagine watching your data go, oh, look, it's in the DMZ now. Oh, look, it's crossed into the other company. Oh, look, it's arrived at the system. Oh, look, they've confirmed they're processing this thing now. And if it didn't get there, maybe it would retry for me. It wouldn't come back to me. It wouldn't be my problem. The middleware would retry for me. And if something terrible happened, like a transformer fire taking out something, it would send it back to me and say, something really bad's happened here. Isn't it amazing that we have better delivery tracking for packages in the physical world than we do for data packets? Isn't that amazing? So what it kind of looks like, and this was alluded to earlier, is the lines between the boxes. The lines are the important part. The lines are the difficult part. If you look at a large organization, it'll have thousands of systems. I think JP Morgan's current system count is 6,000. Bank of America, 4,000. And these systems aren't uniformly spread around. They're spread around in different islands of politics. This is really kind of interesting, this flashing on and off thing.
No, it's not that.
So you know what it is.
I have no idea.
I shall wait for technical support to sort this out.
Right.
You're going to use a different one. That's really risky.
No risk, no fun.
I'll talk while this goes on. Those political boundaries are really important because they're the parts you don't control. So the system you're trying to communicate with is owned by someone else. So when you go to construct one of these lines, you're not doing it yourself. You have to negotiate with someone else. You don't get to choose their technology. You don't get to choose when they build it. And this is the things that we don't really think about very much as developers. But you discover about it when you try and schedule the change. They go, well, yeah, we can do that in 8 months' time. And that's a real problem. So this interbusiness. We forget that we're supporting businesses. Someone's paying us these salaries, and they're making more money to do that. And intra-system connections. And a big part of our job in IT is to manage these connections. And the biggest pain in the head is managing these connections. So wouldn't it be really good if your kind of operating system came with software that made this really easy? It doesn't. The nearest thing we have is, bizarrely, secure file transfer protocol. And if you know how that works, you know how really weird and bizarre that is. It's not really, it's a bit fragile. It was never really meant for this. And people say, no, John, APIs, HTTP, hang on, there's HTTP, APIs. Well, lovely idea, but the problem is you have to build too much, and they have to build too much. Now, you go back to what I said earlier. They have to build something. Someone has to pay for those expensive engineers to build it. You have to agree what it is. You're going to work out a protocol? Yeah? That's expensive, slow. You're not going to get it done. And I remember talking to the chief technology officer in my startup, and he was very, very keen that we'd have an HTTP API, and he just went, Mark, the clients aren't going to use it. They're just going to want a file. I went, but build it anyway. We talked to them. They want a file. And every client wanted a file because they don't have the time to build them. So we have solved this now. We are living in the future. Your AMQP is ready. You have 7 different implementations of AMQP that you can install with a simple Docker pull command. All of them are industrial strength. Some of them are open source. All of the clients of these products can talk to all of the servers without a recompile. That means if I choose to run RabbitMQ and you choose to run Microsoft Service Bus, we actually don't need to know. We just need to know we're doing AMQP. My RabbitMQ will talk to your service bus across the company firewalls. That will work. That's pretty amazing. And how long has it taken to get here? And that's what this is the story of, how we got here. So I've got a timeline. Along the bottom, there's a progress bar. And it starts at 2002, which is incredible. It's older than QCon, right? It's older than AWS. It's older than me. And on the right, there's today. And everyone knows this XKCD cartoon. You know, how do we'll need one standard, one ring to rule them all. The N standards plus one. And we're all very aware of this cartoon and how true it is. And I really, really didn't want to do this. I really didn't want to do this. But someone's got to fix it. But I didn't want to do it. I'd been working on something called FPML, the Financial Product Markup Language. And it was a way of describing financial derivative products. And it's really good. And we started doing that in 1999. And it took 8 years to make FPML version 5, major version 5. That means every version in between was completely incompatible with the version before. Tons of arguing inside our company before we went and argued with other companies, and we argued a lot and built protocols that we didn't like, that were too complicated. And eventually we got to FPML version 5, which is really good. It really is. If you want to learn how derivatives work, it's a fantastic way of learning. So I knew how painful this was. I knew how passionately people get involved in this stuff. You know, we like complexity. We get into the problems. We really wrestle with them. And our way is right. Our way is right. Their way is wrong, right? Solving the problem's easy. Agreeing to do it the same way, that's really hard. You can write a middleware, it turns out, in a week. It takes a lot longer to get everyone to agree to do it the same way. But that's where the value is. So I really didn't want to do this. But we did. We did. In 2003, the story at the start actually happened. And that story really illustrates why you need standards. You know, if you're exposed, dependent, beholden to a single supplier of a technology, the temptation for that supplier to turn around and extort you becomes ever greater the more successful your application is. So do multi-cloud. And I've seen this, and I've worked in a lot of places, you know, at least 60, right? So don't try and guess where these are. I've personally been in a room where financial extortion by a vendor has happened 4 times. The largest number was 200 million. It's very expensive not to have standards. So that first story is illustrating it. And this is why you have AMD to go with Intel. The US Department of Defense didn't want a single supplier. They had seen this game before, so AMD was able to do x86 as well because of that. But here, we had to solve a business problem. The business negotiated with the vendor really hard, and they managed to secure a 3-year extension at great, great cost. And they resolved never to pay the vendor another cent. They were really angry. This had come from the inside the company. They were properly angry. We had to get this thing out of a dozen systems, and we had 3 years to do it, and a very hard deadline. So the business didn't want to do it. Here we have this opportunity. It's an opportunity to, at first, a lot of the systems could just be moved to market data systems. Standard market data systems were working really well now. This is 2003. That TIB-RV was a thing. The Reuters feeds were all working. It was great. So we could just move a whole bunch of the systems straight onto that. But that one system with 1,000 traders in 5 continents, the way it worked, it couldn't just be moved. It needed something special. It needed a specific solution. So this represented a really rare opportunity for a business to fund a technology advancement. I made my pitch. I said, we can do this. And the senior management, rightly wary. They thought, is there any other way? Well, we really don't want to give you technology guys actual money to write stuff. We've seen this game before. It's kind of high risk. We've got 3 years. It's going to be a literal drop dead date. So they thought, well, can we negotiate even harder with the vendor? And so they tried that, and they realized that, no, the vendor knew too much about us, and they thought that they had us completely. The second thing was, well, can we turn the system off? Do we need this? We're about to stop trading equities this way. Program trading, auto trading, high-frequency trading. These are all coming. No, we still need this. Can we bypass the license manager? Well, funny you should say that. My people tell me we can. But no, we're not going to do that. We're not going to do that, which says something, actually, about the firm. So we decided to do it. So JP Morgan was going to commoditize middleware as a side effect of a business problem. Just let this sink in. This is Hursley. Hursley in Winchester. It's a stately home. And it happens to be the home of IBM's mainframe business and IBM MQ series. MQ series was a $2 billion business, I think. I don't know for sure, but I think it was $2 billion business a year back then. And like you do, we had a sort of enterprise visit to IBM. The JP Morgan people and the IBM people, we got together and talked stuff. And there were 10 of us down one side of a table and 10 of them down the other side of the table in this grand salon. Imagine it, right? And we're chit-chatting through the day. And halfway through the day, my boss turns to me. He's a chap called Mark Etherington. Mark turns to me and says, John, tell them what we're going to do. And I kind of look at Mark, telepathy. And he goes, yeah, go on. And so I turn to IBM. And just imagine this. And I just say, we're planning to commoditize middleware. That was the extent of my presentation. And there were youngsters, the young engineers in the room. There was silence first, dead silence, and then smiles broke out among the younger engineers, and then looks of grave concern broke out among the older engineers. And that is the only thing I remember from that day. So, I'm really going to do this thing I didn't want to do. And I had to have a little chat with myself because I'd seen this rodeo before. First, I'm technical. I kind of know what I like. I'm going to have ideas. My ideas will probably not survive this process. I am going to be okay with that, I told myself. The second thing is, the mission is to commoditize middleware, not for ours to win. That's a really interesting difference. If we commoditize middleware, but AMQP is not the answer, that's okay. That's a really important thing. The next one is, I knew technology guys were going to get passionate. They were going to give of themselves, give of their souls to this process. They were going to give exorbitant amounts of time, above and beyond the Call of Duty. They're going to get really wrapped up in it. I resolved that contributors should be able to leave their mark, put their fingerprints on it, go, that's mine. It's a little something, leave a mark. And the last one, I really love technology. But my job is to make this happen, to keep it alive. That's what my job is. Who else cares about standardizing middleware? Who else is that silly? Who else works in an organization that actually knows how to do this stuff really well? Telcos, the actual software vendors, and banks. And only the big ones, Us, Morgan Stanley, Deutsche, Goldman's. We know how to do this. Who else does? And who else can mobilize $1 million a year to make it happen? It's an unusual set of qualifications. So my job is to make it happen. So as I said, AMQP was just a side effect of the business process, the business project. And I was going to call it a message queuing protocol. Yeah, we all like our IT jokes. A message queuing protocol. Has to be 4 letters. HTTP, AMQP, SMTP. Yeah. Has to be 4. It's the industry standard. FTP, oh, ignore that. SFTP, that's why we have SFTP. SSH, ignore that too. So we had a clean room team. Clean room team? Come back to that in a second. We had a messaging team. We had an integration team in Glasgow. And we had our test migration team in India. There were 25 people involved in this. And at the end of this, we planned to roll this out to the 1,000 traders in 5 continents without a hitch. That was the plan. So patent risk. Does anyone remember being afraid of software patents? Yeah? You've got the Alice Corporation ruling in 2014 to be thankful for, that we're no longer afraid of software patents. Most software patents, unless they're bound physically to hardware, are now essentially irrelevant. A business process patent can't be held. If anyone ever has the opportunity to stop software patents coming back, because people are trying to bring them back, make sure they don't come back. They're hell. My point of view may be clear. So the patent risk was really, really real in 2002. So we worked out that, with patent risk, you're sued really for making. Making is the bad thing. Making is what's going to get you in trouble. And people who are patent trolls, they go after the guy with the deepest pockets. Being called JP Morgan doesn't help at this point. So we really knew how to do this. We resolved that we're going to specify this really, really well. We're going to draw on the expertise of the firm and specify this really well. But we would not make it. We're going to pay another company to actually make it following that specification. So I went set out to find a company that would be good to make this sort of stuff. And I found Imatics. I Googled, and I found Imatics. And I liked Peter Hinchin's work. Peter Hinchin did work on code generation, on state machines, on web servers. He knew middleware. He kind of really got the vibe. I loved his communication style. And he loved the vision. And we decided to work together. I need to say at this point that Peter is no longer with us. Very sadly, he passed away well before his time. But he was one heck of a character. And Peter made the first non-JP Morgan contribution. The first fingerprint was Peter's. Peter said, and if you knew him, it must be exciting. We can't call it a message queuing protocol. It must be the advanced message queuing protocol. And so it was. That's how it got renamed. And I contracted Imatics to build the broker in C. Why? You're all going, why? I wanted to make this an operating system solution. I wanted to make it palatable to those guys in Linux land. Apparently they have issues with other programming languages. So, you know, and I thought, well, we're going to do the hard one. We're going to do the difficult one, and then other people can write the easy ones, you know, Java and stuff. And I committed. C is so hard. Just build your own bricks. Why don't you? And I committed to assign co-copyright of the software to Imatics if we went live successfully. You know, so we pay you to build it, and if it goes live well, we'll give you the software, and we'll pay you for support contracts. We want that business to succeed. We want this to work for you. So around about this time, ActiveMQ appears in the scene. ActiveMQ may have been the first commercial open source middleware and built by James Strachan. And ironically, James Strachan had actually worked for JP Morgan at one point and had actually made a commit to the system we were upgrading, which is just like the world's a small place. And James had just come from making the Groovy software language. He's a really talented guy. And I thought, this is fantastic. Maybe I don't have to do this. Remember, I really don't want to do this. Maybe I don't have to do this. And so I met with James on Fleet Street on a sunny day. We sat down, had a chat, and I tried to convince James that standards were the way. And James didn't see the value. James just said, just use ActiveMQ. Commercial open source. The commercial imperative to be sticky, to have a USP, to be differentiated, to be able to sell. This is the fundamental tension between standards and vendor commercial proprietary products. But when AMQP started making mindshare, James reacted. He published OpenWire, which was essentially a dump of the symbols from ActiveMQ. Call it protocol. So we're still operating in secret at this point. And we're doing everything under ANDA. I'm running around talking to other banks. I'm running around talking to all these software companies, IBM, Cisco, all manner of companies, Sonic Software, Solace Systems, 29 West, all manner of companies. We're kind of good at doing that. But I have this guy working for me, a guy called John Davies. And John's a serial entrepreneur. People in this room undoubtedly know John. And a big character. And he was between entrepreneurial gigs working for me. And he thought AMQP was the most interesting thing that the bank was doing. And he went to New York one year and went to the Web Services on Wall Street conference in 2005. And he just couldn't help himself. He blabbed. In fact, he more than blabbed. He stood up and told everyone. John's a big guy. He's got a lot of presence. And people sat up and listened. And the press were in the room. This is one of the thin extra. JP Morgan promotes open source messaging system. And John's name's in there. And I was kind of annoyed. This was quite a fragile project. We were doing it in the QT. We were worried about patent risk. You know, this was kind of, I went, this is not good. Right? But it was good. It was good. Because in that room was David Ingham. David Ingham worked for Microsoft, and David thought, oh, that sounds interesting. And also, John Davies is friends with Alexis Richardson. And Alexis was the founder of RabbitMQ. And that's how Alexis learned of AMQP. So John, all is forgiven. I think what he did that day was very important to this journey. 2006 was one heck of a year. In 2006, we had AMQP 0.9, a 130-page specification that was really good. I thought that. And Imatics were in the middle of coding the C. And they had decided to do it in multi-threaded. I mean, what's worse than C? Multi-threaded C. Read Rust, you know, to understand what's going on there. And they were having some problems. This thing was not passing acceptance testing. And months went past, and it just kept locking up. And if you program multi-threaded C in the early 2000s, Linux didn't really do threads properly. You know, there's lots of things didn't work. Today, everything works. Back then, nothing really worked. My project manager, Steve Connolly, was really getting quite concerned. And we sat down and thought, we need a plan B. It's time for plan B. We have this super hard deadline, plan B. And one of my guys in Glasgow, a chap called Robert Gregg, had written the JMS API for AMQP. We were doing the Java stuff because it's easy. And they were doing C stuff because, hard. He'd done a really great job on the JMS API. And I went to Robert and said, could you turn the JMS API in Java into a complete broker server implementation? He went, I'll have a go. And 2 months later, he had done it, and he'd done it really well. Robert was a talented guy, is a talented guy. And, but OpenAMQ was fixed at that point. The C one, which is called OpenAMQ, got fixed, and it passed its tests in May, and we went live in November. And the business project is a success. We roll this thing out to 1,000 traders in 5 continents, and we have this ability to do a slider. Old middleware, new middleware. And we had bridging technologies and all sorts. And the clean room stuff I talked about earlier was because of the litigious nature of the whole relationship, we had an independent team analyzing what the system did and creating specifications for us to map it onto. It was a big deal. It's a huge project. And we were able to just go slide, and the business didn't skip a heartbeat. It was a tremendous success. And the execs were really, really happy. And because of that, I was really happy because we were able to assign the copyright, co-copyright, not exclusive copyright, we had learned that one, to IMATIX for OpenAMQ. So that was a win. Now, lots of stuff happened in 2006. 2006 was we came out, we went public, we stopped being secret. The AMQP working group, which lasted from 2006 to 2011, started in June 2006. And JP Morgan, Cisco, there's a great quote here. Whenever another large middleware company learned of Cisco's involvement, they called up the guy and said, why are you doing this? He went, you've had a good run, but it's over. IMATIX was involved, Iona, which is now Progress, Red Hat. And we had this legal structure. It was a cooperative arrangement. There was no legal entity. No legal entity. It was a whole cooperative contract structure that also had a big amount of licensing patents involved. So we had defensive mechanisms built into this. And Red Hat and Cisco had such huge patent portfolios, we felt we were wrapping ourselves in safety, because this is still a problem. 2014, we're not there yet. Patents are still a thing. The Linux guys were suing each other. And Andy Cadell, the chief intellectual property lawyer at JP Morgan, helped us do this. And it's a really fantastic set of arrangements. And it's worthwhile looking at the agreement structure. And we would meet every Wednesday. Come hell or high water, that call happened. And over time, we grew and grew and grew and grew. Still 2006, what a hell of a year. So Red Hat, Carl Treloff was at Iona, moved to Red Hat. And Carl wanted to give Red Hat a middleware story. Enterprise company, middleware. And he talked to Peter at IMATIX and to acquire AMQP knowledge. Because Red Hat didn't know anything about this. It's kind of moving, and we're kind of part of it, but we're not part of it. We're not really in it. We need those skills. How do we get them? And so he talked to Peter about some sort of arrangement, and Peter declined. Peter declined to partner with Red Hat. He said, we'll go alone. And that was his prerogative, his right. But it really upset me. I thought, I want OpenAMQ in Linux. I kind of like the idea of installing Linux and getting middleware. This is kind of, you can see where this is coming from. So it was unacceptable to me that Red Hat did not have skin in the game. And so we took Blaze, which is what Robert had called our broker, and it's still used. We took Blaze and we licensed it to Red Hat and Iona very discreetly. And Red Hat took that and championed it into the Apache Software Foundation. And Blaze was a highly trademarked name, so Apache said, we can't have that, rename it. So we called it Cupid. So Apache Cupid came into existence in the incubator in 2006, became a top-level project in December 2008. And it's very widely used. It's not got anyone really pushing it, but it's used all over the place. There's over 40 systems in JP Morgan running Cupid. It's bulletproof. But it's kind of the Switzerland of AMQP, Cupid. Neutral ground. So, turns out Rafi Schlomming at Red Hat, one of the engineers there, he really had a thing about working on projects that had Star Trek themes. And Cupid is named after Q, this character here, who's from Star Trek Next Generation. He's one of the villains. He's an omnipotent character. So Cupid, Riffy got his fingerprint on this by naming it Cupid. Still 2006, one hell of a year. RabbitMQ begins. So Alexis Richardson had learned, he'd wanted to build a financial messaging product. And he'd learned about AMQP's existence from John, from earlier, John Davies. And John had gotten him a copy of the specification. And Alexis was working with a company called L-Shift. They were a boutique consultancy in Hoxton here in London. And Matthias Radstock and Tony Garlick-Jones, they were kind of doing the prep work for this whole thing. And they were looking at Erlang. And thought, this is really interesting for writing distributed systems. And whenever Matthias saw the AMQP spec, he got the joke. Because the AMQP spec is beautifully formatted PDF document, but the source code for it is XML. Come back to that in a second. And they realized they were able to code generate a huge amount of the implementation directly from the specification. Talk about that in a second. So they had a broker put together on Erlang really quickly. And in February 2007, RabbitMQ is released to the world. And because it's leveraging all of Erlang OTP, it's immediately fast and robust, and it gets this reputation for just working. Now, Alexis and the team were amazing entrepreneurs. I watched them doing developer evangelism. They really ignited passions around this thing. And if it wasn't for them having chosen AMQP and them having been so successful with developer evangelism, I don't think we'd have got as far as we have got. Rabbit was a really big part of the story. Their developer education, everything, the passions people had. To a lot of people, RabbitMQ was AMQP and AMQP was RabbitMQ. A lot of people. And that was interesting. So, a machine-readable specification. One of my contributions to the project was to make the spec machine-readable. You know, we had this fanatical thing about making the spec extremely complete and unambiguous. I'd seen ambiguous specifications before. If you look at the IETF and some other places, you'll see specs. You go, how the hell do you build this thing? There's just not enough information. And I think that's deliberate. I think some vendors half specify things to make it impossible for competitors to know how the secret sauce works. But that's not useful. And I had actually tried to implement one of the Corbett event service one time, and I thought, how the hell does this work? And I've discovered that no one had ever built it before. We resolved not to do that either. You know, this spec has been built multiple times. But inside it, there's kind of an IDL. Leave through the XML that's used to generate the PDF. There's all this data that you can use to write a program, to read the spec, to generate code in the language of your choice. And you've done half the work in a day of making a new client for AMQP. And the community around Rabbit really seized on this, because they kind of liked their eclectic technology. So you had a Go client appeared. Everything appeared really quickly, because the community got the joke. And another thing I'd done with that I'd insisted in the protocol was to make it asymmetric. It was much easier to write clients than it was to write server, and that really helped. 2007, you see our progress bar. It does get faster towards the end, don't worry. 2007, ACMQ reached out and asked me to write an article for them, which is great because it kind of added an air of enhanced legitimacy to what we're doing. That was the second most cited article in that particular queue. I don't know what the first one was. This is an interesting one. So I'm sitting at my desk in JP Morgan. It's in the afternoon. My desk phone rings. Desk phones never ring. You know, why do we have them? You know, in the year 2000, Cisco was the largest telephone handset manufacturer in the world. We all had one, and they never rang. I pick it up, go, hello? Hello, John. You know an awful lot about me. How'd you get my number? So the Department of Homeland Security here. These are not words that strike warmth and coziness into your heart. I thought, what have I done with my visa? Did I leave the little green slip in the visa going to New York or something? And they went, no, we just thought we'd call up and tell you we've decided to standardize the Customs and Border Patrol protocols on AMQP. And they processed $2 trillion of revenue a year. I think with Donald's changes recently, it might be more than that now. Sorry, but they were really big on this. And Wolf Toom, his actual name, Wolf Toom, the CIO of the Department of Homeland Security, CBP, they joined the working group, and they really were very active participants, very good participants. Still, 2008, Microsoft joins us. Took them a while, but they join us. And David Ingham, the guy in the audience at that conference all those years ago, became the editor of the AMQP specification. It was a neutral role, and he performed it fantastically well, very well liked. Now, we didn't see much surface area from Microsoft. The day they joined, our website traffic to amqp.org quintupled the day they joined. They got their own gravitational field. And we had the sense that something was happening behind David. You know, they were doing something, but we couldn't tell what it was. So, 2008, we sort of sit back in a chair and go, have we just won? Has this worked? Did we actually achieve everything we set out to achieve? You know, Rabbit helped us correct a few errata in AMQP 0.9. We got 0.91, which is a very robust and delightful protocol. And we have these multiple high-quality AMQP 0.91 implementations. And it's being rapidly adopted, but it's not a standard. It's not a standard. It's just our little project still with lots of people, but not standard. Now, if you've ever started an initiative, or if you've started a company, and Alexis inspired me to start my startup. I turned down a job offer at Goldman's, and I started my own company. Because, hey, life's too easy. And watching him, that was really inspirational. But if you start a company, VCs have this phrase, default dead. You know, you have to come into the office every day and make your company be alive. You're willing it into existence. And the same was true with this. It's default dead. You know, every day you have to come in and will it along. You know, people come along for the ride because they see you're dragging it from front and they're clapping. You know, it's fantastic. Keep going. And then one day, it takes on a life of its own. And you might not even notice. It's actually quite hard to notice when something stops being default dead. And I realized that AMQP was default alive at 0.91. And in particular, the AMQP working group, their work was not yet done. I'm running out of time here. I can't believe that. I'm going to have to really haul me off the stage. So the first breaking change, the working group, the experts that were joining, really hardcore experts, they wanted more. Spell M-O-A-R, more. And they proposed they wanted to have much stronger session transport. And it was the first breaking change. And they terribly named 0-10, because it looks like 1. And nobody liked this version of the protocol. The people who used 0.91 didn't like it because it was a breaking change. 0.91 was fine. The people who wanted more didn't like it because it didn't go far enough. So we ended up with this terrible secret that confused the heck out of everybody. We had 2 protocols. You think, they just evolve. No. From 0.91 to 1.0, yes, it is true, it changed completely. This is a massive thing. It went from being broker-centric, asymmetric, competent, easy-to-write clients, strongly defined queues, difficult, impossible to retrofit onto existing products. We kind of like that, right? That was a sort of passive-aggressive thing, my part, I think. It was user-friendly. And the 1.0 draft was brokered or brokerless. Ooh. Symmetric. World-class transport. This thing smells like InfiniBand. You know? It's really hard to read, and I'd recommend you look at Clement's Clement's documents at Microsoft? He's got some fantastic descriptions of how the protocol works, but it's awesome. It's properly awesome, and not at all easy to understand. Very hard to write clients, loosely defined queues, and therefore much more easy to retrofit to existing products. It's vendor-friendly, and exchanges are gone. This key concept that people knew AMQ because, oh, it has exchanges, and no one quite understood. They're gone. So in our San Diego offsite in 2009, I stopped and took this picture. I just thought, oh my goodness, we have maybe the brains trust of middleware, with the exception of the 2 largest firms in the space, in this room. We have 29 West, we have Solus, we have Goldman's, we have Credit Suisse, we have JP Morgan, we've got Red Hat, we've got Cisco. It's like, what? They're in one room together. And the protocol looked amazing. Great work. And the public day we had, a whole bunch, this is San Diego, it's kind of the middle of nowhere, really. A lot of people flew in to see what was going on, and they approved. They liked what they saw. And this is a terrible place to have a conference. So Matt, in the back in the blue shirt there, Matt Arrett, he was working with the National Science Foundation Oceanographic, I can't even pronounce it, survey initiative, and they were using AMQP in submarines and stuff like that. And they funded Scripps Institute being able to host the conference that year. And the people involved in this all really liked each other. It was a fantastic camaraderie. And we became really friendly. A lot of us became friends. Mostly. Ematics goes its own way. So Peter wanted AMQP to stop at 091. But it was still evolving. The community was taking on, it was out of anyone's person's control. I think Peter thought I controlled it, but this has gone out of my control now, remember? I'll not be upset if it's not my ideas. Ematics had sales, but RabbitMQ was winning. And he got angry and went in the opposite direction to something he could control. And ZeroMQ was born. And ZeroMQ is a lovely product in this particular niche. It's in Jupyter notebooks and all sorts of stuff. And the result, ZeroMQ, the clue is in the name. No queues, no broker. And Peter loudly objected to AMQP's evolution and, and actually used that railing against us to publicize ZeroMQ. Eventually, he abandoned OpenAMQ as well whenever our support contract expired, which is unfortunate. So that kind of died. It's funny, you see products succeed, products dying. Rabbit, the succeeder, gets even stronger. In 2010, they're acquired by SpringSource, which is amazing. Right? And then SpringSource is immediately acquired by Pivotal Labs. This is becoming a multi-billion-dollar organization. Then Pivotal Labs is ultimately acquired by VMware. And this really burnishes Rabbit's enterprise credentials, strength to strength. At this point, IBM kind of notices that all is not well in the middleware world. This was not the plan, and we could hear whisperings. They'd never say anything publicly, but we could hear whisperings on the back channel. And they released MQTT. And MQTT is super simple, super easy to use. It's really good. It really is genuinely good for IoT, Internet of Things applications. And it's definitely not an MQ series competitor, which means it's not an AMQP competitor. But it was thrown out there to queer the pitch, to distract, to take away attention from us. It's light, it's sexy, it's cool. Internet of Things. And I know I have it on good authority. This was deliberately done to do that. And it started tracking the same processes as AMQP. It started tracking Oasis, it started tracking Apache. So after 16 years of having a whale of a time at JP Morgan, I get headhunted by Bank of America. And they join the working group. And now we have 3 of the top 5 US banks are members of this little AMQP working group. And Matt Arrett becomes co-chair because I've got this new job. I've got to really knuckle down and do things, actual work. And JP Morgan starts to transition Cupid towards Red Hat. I'm watching the time here, got 2 minutes left. How long can I go on for? Someone tell me. So we now have this period where we've got a specification that's really good and no products to implement it. We've got tons of things to implement 091, but that's not what the working group wants. The working group wants 10, and no product implements it. So we've got this 2-year wait while engineers meet in rooms around the world, around tables huddled with laptops and coffee, trying to make their software work together. Lots of connectathons. And in the meantime, while they're doing that, we get to decide, because we never meant the AMQP working group to be permanent. There's no legal entity. We get to decide where we want to land the standard. Where's it going to go? We need 2 independent implementations to qualify. Where's it going to go? The Internet Engineering Task Force, super cool, bit anarchic. ISO, super cool in the other way, quite inaccessible. W3C, webby stuff, not us. No, really, just wasn't us. And Oasis. And Oasis is a really nice standards body. And we liked them, and we liked their processes. Really easy to work in their construct. And also, they were affiliated with ISO. So there's this chance that maybe we could follow the path up to the big standard. So in 2011, we have the launch party. And this is at 270 Park Avenue. And if you know New York, this is the building they're rebuilding. This is the giant edifice that's being rebuilt in the middle of Midtown. And there's 100 guests there. And we had lots of companies, lots of vendors, Software AG, Red Hat, Microsoft, Rabbit, stood up and made commitments in public, attestations of support to the one true protocol. Sorry, did I get carried away there? They had running software products. We had live demos in the room that day. Real products, more than 2, eligible for standardization with a capital S. And this is who was in the interop demo. Microsoft, Apache Cupid, RabbitMQ, StormMQ aren't with us anymore, but they were great people in that. And InfoQ are good friends of mine. Angus Telford there did a whole bunch of stuff just because he was passionate about technology. So time passes, 2012, a year passes as the wheels of standardization grind. Nothing changes about the protocol. It doesn't change at all. We get rubber stamped. We are an OASIS international standard. It just took 10 years. This is 10 years from the starting point. And remember I talked about how difficult it was to write the transport in AMQP 1.0. Apache Cupid ended up being the parking lot for lots of software to make it easy for people to write that transport. Now, we decided to go for ISO, and Microsoft helped us. Minus 57 seconds. Microsoft helped us. And that's a difficult process, because countries vote on whether you should become a standard. And a majority of countries have to agree. So as an interstitial, it'd be interesting to think about the participation rates. At the end, 60 people were involved in making that international standard, and participation had grown in every single version of the specification. In the end, 91 people have been credited in some version of the AMQP specifications, but there are hundreds more who took part in this, and I really want to thank them. We couldn't have done this without all those people working together. It's not an engineering problem. I'm going to end now. It's not an engineering problem. It's a people problem. So I'll skip through this. We become ISO 19464. ISO has a very strong gravitational pull. All the products converge. It takes a while. All the products converge. All the products converge. All the products converge. 18 years after that meeting in Hursley, all the products converged. I didn't notice it was done very quietly. MQ Series 9.3 is AMQP 1.0 compatible. It made me smile. Mission complete. Here's some numbers you need to know. RabbitMQ is the most widely deployed AMQP implementation with 54,000 customers and 1 billion downloads from Docker Hub. Microsoft have the largest AMQP 1.0 infrastructure. They process, get this, 10 trillion messages a day on Service Bus. And they're all AMQP 1.0. The entire that's what they were doing quietly in the background. They architected the entire thing around AMQP. It's amazing. What did we learn? Very, very quickly. A dedicated leader is necessary. I didn't expect how much this would be a people thing. Everyone needs a business case. It's not obvious. You need a business case. Every individual needs to know why they're there. If they don't have that, they won't be able to stay the course. It will take longer than you think. Get the resources. Find a standards body earlier than we did. Specify comprehensively. You will not regret it. A lack of backwards compatibility can be fatal, but it didn't kill us. A product is not a standard, James. Anybody else? Don't formalize until things work as they expected. Vendors and users have fundamentally different needs. The needs between a vendor and a standard are different, but you have to accommodate them and balance them. And that's what we did. We had AMQP, ISO 19464, world-class messaging for everyone. Thank you.